Good day everyone, I am Lakta Katangkay and today we're going to talk about the modern physics. Galilean relativity. Galilean relativity states that the laws of mechanics must be the same in all inertial frames of reference. There is no preferred frame of reference for describing the laws of mechanics. Also, Galilean relativity is approximation of the special relativity valid for low speed. Galilean relativity include non-Euclidean geometry to represent gravitational effect as the geometric curvature of space-time. The speed of light. According to the electromagnetic theory, the speed of light is approximately 300,000 km per second, meaning if you look at the sky at night, these starry skies may look close to us, but their beams from the Milky Way may have actually originated hundreds and thousands years ago. Luminous ether. Assumed to be present everywhere, even in empty space and light, waves were viewed as either oscillations. Absolute frame is a special frame of reference at rest with respect to the ether, which the laws of electromagnetism will take on their simplest forms. Michelson-Morley experiment. This experiment was performed by Albert Michelson and repeated by Edward Morley. This theory aimed at finding the speed of the Earth through the ether. The result of the Michelson-Morley experiment showed that either there was no ether or that, if there was an ether, the Earth was not moving through it, and light is now understood to be an electromagnetic wave that requires no medium for its propagation. The theory presented by Albert Einstein in 1905 is based on two postulates. First is that the laws of physics are invariant in all inertial frames of reference. Second is that the speed of light in vacuum is the same for all observers regardless of the motion of light source or observer. In relativistic mechanics, there is no such thing as absolute length or absolute time. Further, events at different locations that are observed to occur simultaneously in one frame are not observed to be simultaneous in another frame, moving uniformly past the first. A basic premise of Newtonian mechanics is that a universal time scale exists that is the same for all observers. Newton and his followers simply took the simultaneity for granted. However, Einstein abandoned this assumption, so he conducted an experiment to disprove Newton's statement. Time dilation. The time interval between two events measured by an observer moving with respect to a clock is longer than the time interval between the same two events measured by an observer at rest with respect to the clock. Meaning, time dilation is a difference in the elapsed time as measured by two clocks due to relative velocity between them. This is our sample problem. Suppose we observe a rocket ship moving past us at 0.85 c. We measure the time between ticks on the rocket ship clock to be 1.67 s. What time between ticks is measured by the captain of the rocket ship? Here's a solution. Ang gagawin lang natin is substitute. t sub 0 equals t square root of 1 minus v square over c square. Ang kalalabasan niya ay 1.67 seconds times square root of 1 minus 0.85 c square over c square equals 0.880 seconds. Next is the twin paradox. Twin paradox is an intriguing consequence of time dilation where the age of two people has different reference before and after the situation. An example of twin paradox is shown at the right where Speedo takes a journey to planet X times 20 light years away and returns to the Earth. Next, the length of contraction. Length of contraction takes place along the direction of motion. The formula for length of contraction is L equals L sub O square root of 1 minus V square over C square. Here's a sample problem. A rocket ship is at rest with respect to us. Its length is 100 meters. How long do we measure its length to be when it moves by us at a speed of 2.4 times 10 raised to 8 meter per second or 0.8 c? Here's our solution. L equals L sub O square root of 1 minus V square over C square magiging 100 meters square root of 1 minus 0.8 c square over c square equals 60 meters. Next, relativistic momentum. Relativistic momentum, it relates the definition of the classical momentum into the factor of y in order to have the momentum at all inertial frames. Here's a sample problem. An electron which has a mass of 9.11 times 10 to 31 kg moves with a speed of 0.750 c. Find the classical momentum and compare it with the relativistic momentum. So here's our solution. The classical relationship between relative velocities according to the Galilean relativity was V sub AV equals V sub AE minus V sub BE. When observers E and B are in relative motion, they will measure different velocities for some third object. Those measurements are related by the equation below. As you can see in the equation. At low relative velocities compared to that of light, this expression agrees with the Galilean form where it can be inverted to give the equation of relativistic velocity addition. The equation above gives the intuitive answer agreeing with the everyday experience. Here's our sample problem. Relativistic energy. Kinetic energy is the formula for kinetic energy was modified by Einstein to its relativistic form to be Ke equals ymc square minus mc square. The constant term mc square, which is independent of the speed of the object, is called the rest energy. The relation above shows that a particle stationary with respect to a given observer has a kinetic energy of 0 and an energy proportional to its mass. Here's our sample problem. This special relativity only relates observations of inertial observers. The two postulates of Einstein's general relativity are as follows. All the laws of nature have the same form for observers in any frame of reference, accelerated or not. In the vicinity of any given point, a gravitational field is equivalent to an accelerated frame of reference without a gravitational field. Now, let's proceed to the quantum physics. Thermal radiation. Thermal radiation is the only mode of heat transfer that can occur in a vacuum, which makes it fundamental to survival of all species in the universe. The black body is an ideal system that absorbs all radiation incident on it. The peak of a black body radiation curve is given by the Wien's displacement law. Resonators. Max Planck hypothesized the submicroscopic charge oscillators produced in black body radiation called resonators. The formula for resonators is E equals NHF. Next, what is photoelectric effect? Photoelectric effect is a process whereby electrons are ejected from a metal surface when light is incident on that surface. By extending Planck's quantum hypothesis to electromagnetic wave, Einstein provided a successful explanation of this effect. Here's a sample problem. X-ray was discovered by Wilhelm Röntgen in 1895 and much identified as electromagnetic waves following the suggestions by Max van Loo in 1912. It is produced when high-speed electrons are suddenly decelerated, when electrons have been accelerated through a voltage. The X-ray spectrum of a metal target consists of a broad continuous spectrum plus a number of sharp lines, which are due to characteristic X-rays. Next, the diffraction of X-rays by crystals. The condition for constructive interference of the diffracted rays is given by Bragg's law, which was derived by W. L. Bragg. Bragg's law bears a similarity to the equation for the diffraction pattern of a double slit. The Compton effect. X-rays from an incident beam are scattered at various angles by electrons in a target such as carbon. In such a scattering event, a shift in wavelength is observed for the scattered X-rays. The phenomenon is known as the Compton shift. Conservation of momentum and energy applied to a photon-electron collision yield the following expression for the shift in wavelength of the scattered X-rays. Here's a sample problem. Next, the dual nature of light and matter. Light exhibits both a particle and a wave nature. De Broglie hypothesis. Louis de Broglie postulated that because photons have wave and particle characteristics, perhaps all forms of matter have both properties. He also proposed that the frequencies of the waves associated with particles obey the Einstein relationship E equals h times f. De Broglie wavelength formulated to combine the wave theory with particle theory to calculate the wavelength of any particle whose mass and velocity are known. Here's our sample problem. Wave function. A quantity describes each particle described by Erwin Schrödinger. The probability per unit volume of finding the particle of a particular point at some instant is proportional to The quantum mechanics has been highly successful in describing the behavior of atomic and molecular systems. Werner Heisenberg introduced his notion that if a measurement of the position of a particle is made with precision x and a simultaneous measurement of linear momentum is made with precision px. In other words, it is physically impossible to measure simultaneously the exact position and exact linear momentum of a particle. Although experiment for viewing an electron with a powerful microscope, the electron is viewed before colliding with a photon, and the electron recoils as a result of the collision with the photon.